Gone are the days when students were content learning through textbooks. The exponential explosion of technology in our everyday lives has spilled over into classrooms throughout Canada. Today's digital learners thrive in media-rich, inquiry-based teaching environments. Student-driven investigation with real-life applications is made possible with tools such as Pasco's Spark Science Learning System and SparkView software.
Spark data logger system really, with its sensors and software, is a way of kind of, marrying software and technology so that students can actually collect really authentic data and a lot of different kinds of data. So they can collect temperature settings, they can get dissolved oxygen in liquids, pH values, heart rate, pressure. There's really two huge advantages of using this kind of learning tool in the classroom. First, it improves student engagement because they're motivated to do something that they know that seems really authentic. And second, it prepares them for the world outside of school, because that's where the world is now in digital kind of data analysis and collection. There are probes that can really meet the needs of almost all curricular areas and units, from junior into intermediate. There's multiple entry points as a teacher. They have a platform where there are labs already on using the software, and so teachers that are maybe a little bit less secure about doing open-ended inquiry can follow those, and they're really rich labs and experiences that students can do. If you're more of a science teacher that wants to take it to the next level, that technology certainly allows you to develop your own lessons in inquiry to meet the needs of your specific learners. And the sky's really the limit, because you can do so many more activities with this particular probeware than you normally would with the kind of crude instruments that are generally found in elementary schools. How about the Sydney kind of Jake thing that's unstable when it's lower? Interesting. And how about that it only can produce 10 as its max? One of my roles actually in the community is I'm the vice chair of the regional science fair, and I've been involved in science fairs in a long time, and I see a tremendous amount of students that have a natural curiosity about their environment and science. One of the things that we're trying to do is actually hook up more students with this technology so that the technology doesn't limit where they actually can go. And so we've actually had some students in the regional area use this technology to really expand their research, which has been really exciting.
Yeah, we went past 30 seconds.
Well, pay it off right there.
Not doing anything, not doing the same thing.
Okay, start a new one, Owen.
I did.
Sometimes we're holding back our leaders, so it's nice to get that technology in their hands.
I like it because it's hands-on. Like, you're not just sitting there writing notes.
You don't have to draw the graph. You could just take the mean, the maximum, and the minimum and just write it down for your results.
And also, it's accurate and it's fast to get your measurements, so you don't have to use like calculators or anything.
The nice thing with the Spark units is that they are very portable. So once they're charged up, you can really go out into the environment and collect data outside traditional classroom settings. So that's nice if you go down to a creek or outside to get temperature or other weather type of data. It's also flexible enough too that you can use it with whole class situations, but it's also been appropriate sometimes, even if you do have science fair clubs or after school science clubs, to have students kind of explore different kinds of data collection at that time too. The SparkView software has a few benefits. The first being that it can be used on multiple platforms. So you can use the SparkView software on the Spark independent units. You can install it on netbooks or laptops, as well as you can put it on iPhones or iPads. And so having that flexibility is really nice. Sometimes you can go out into the environment with a Spark unit, collect the data, bring it back, and actually then show it on a laptop or netbook or even on a desktop, and then put it displayed onto a smart board. Then you'll see something look a little bit different, and it's easier to see what's going on here. The other advantage is it collects the data real time. So gone are the days of spending tons of minutes doing these handmade graphs. They're collecting the data real time, but that gives them then the time to actually analyze and interpret that data, and that's where the real rich learning takes place, not coloring in bar graphs or drawing of a line, but what does that data actually mean?
It's going to stay at 0 for a long time until it melts.
It can't be over 100. 100 is the evaporation point.
And it's one of those things right now that we know that students are weak in is actually the interpretation or analysis of data. So that can be done really effectively using the SparkView software.
If like your teacher told you the result, you'd be like, what? Where if you like use the Spark, you could go like, oh yeah, like I understand now.
When our teacher says that we're going to be using Sparks, our class gets all excited.
A lot of our friends use Sparks inside the science fairs. And I was a test subject for like a heartbeat monitor.
I have several intensive support students, and there's no way you could tell those students. It completely levels the playing field, gives kids confidence in their abilities. They know how to use the probes, they're easy to use. They design their own experiments and they follow through. They're able to troubleshoot and problem solve all the way, and that's regardless of the student's ability. I think the key is that they are easy to use, and they're really accurate and they work. Kids get very frustrated when stuff doesn't work. My grade 8s, when they've designed an experiment around a probe and they go to use it, they know it's going to work. And that gives them confidence. It makes them feel like they know what they're doing. They're real scientists. So in today's experiment, where they were testing the conductivity of 3 different fluids, they got the same result for 3 in a row. And their question was, "Ooh, is it working?" And I think if they were just recording data, that conversation wouldn't even come up. Because they understand the probes, because they understand how to use the technology, they're very able to design experiments on their own. The students are given something that tweaks their interests. They determine variables, independent and dependent variables, and then design their own experiments around the probeware. And again, it creates a more authentic scientific inquiry. When we see these students in small groups, that's when they feel comfortable to ask you questions and to share their answers and to go beyond.
6.8 for the pH, and this one's 5.7. So they're still pretty different, but they're both under 7.
But the fear is that something's going to go wrong, and kids, are going to wreck equipment, or you're going to have serious classroom management issues. And the reality is that when students are designing their own experiments, they're much more invested in the outcome. They're using technology that they're excited about using, and there are no classroom management issues. And kids are 100% engaged in what they're doing, problem solving as they're going along, thinking critically about what they're doing, and the results that you get. The discussions are much more rich at the end.
But when we're all using the sparks, we are a lot more involved into it.
So like if you miss something, or you could look back at your graph or your data.
It wasn't just like the teachers telling us that we had to do this and do that. It gave us a chance to like really experiment, and kind of felt like CSI thing.
In the 21st century, if we want to be globally competitive in the economy, we definitely need to kind of nurture those skills of working with technology and linking them to critical thinking. So in the past, students in science, especially in elementary school, were in programs that were predominantly reading some text, answering some questions, and memorizing facts. That's not really what scientists do. And so one of the huge benefits of using this type of technology in the classroom, it more mimics what real scientists do, and it becomes an authentic learning experience. So that better prepares them for secondary school and science after that.